Okay, so today we'll see about okay. So generics you have already completed. So I will take another class generic. Okay, but the basic definition you already know how to do with the generics, how it is advantages our other approach. Okay. So if time permits, then we will take another class on generic. So So today we will see about time complexity and we'll start linked list. Okay. So this is an important chapter. So listen carefully. So first of all, um, so can you hear me?
Yes, sir.
Okay. So what do you mean by time complexity? So this is a measure. Uh, this means you have to calculate how much time your algorithm or your approach will take. So before that you should know what is the algorithm. What is the algorithm? And what is the difference between an algorithm and a program? Already you were studying programming, so okay. So algorithm is nothing but a part or a superset of set of programs that will help to uh, to um, execute or to run a process, okay, with some set properties, okay. So that procedure or that approach should terminate in bound time, in some definite time, okay. It will have a start time and it will have a end time, and there are certain steps or called set of procedure, okay, which will be executed sequentially one by one, not randomly, okay. So there are set of algorithms which can run in parallel also, but in sequential algorithm, so those instruction or program, so program is a set of instruction. Now algorithm is also superset of program, okay, set of programs or small programs, okay. So each program comprises of certain logic, so it holds certain logic that will help to find the output, okay, in certain time period, and those process will run with certain with the sequential set of programs, okay. So suppose an algorithm have a 2 3 chunk of programs or code snippets, program 1, program 2, program 3. First program is for program 1 is for taking inputs, program 2 is for uh, calculating the average. Suppose there is an example. Program 3 is for applying that average and multiply with another set. Okay. So program 1, program 2, program 3. So this will be executed sequentially. So program 1 should be done before program 2. Program 2 should be done or completed before program 3. Just imagine you are taking water from a well, okay. So your task, the certain task is to take the water. How much water you can take? Suppose 50 liters. 50 liters of water you want to take uh, to fill a tanker, okay. But your bucket is of 5 liter. So you cannot take 50 liter of water from the well with the 5 liter of bucket. Okay, so you will go to the well. Okay, so now you will apply how to bring the water. Those are consist of input part. How to take the inputs, how to process data, all these things. So that will belongs to program one. Now you suppose take the water. You can at most can carry 5 liter water. Now how do you carry and how will you go and fill the tanker, that is a program 2 or program 3. So similarly there are different sets of instruction which comprise this program, that they are called as a submodule of the program, larger program. Okay. So algorithm is a set of those small programs. Now finally you fill the tanker with 50 liter. So how many times you will go and fetch the water?
So 10 times.
Very good. Yes. So 10 time you will go and 10 time you fill the tanker. Okay. So this is one approach you can take. Now there are other approach also. There is also those approaches. Okay. So that may belong to the program which will constitute different algorithms. Suppose I will give you two buckets now. That will be a different algorithm. Okay. Two 5 liter bucket. Okay. Now if I will if you can use conveyor belt from the well to your tanker. So now that is a different algorithm. So algorithm 3. Okay. So similarly those sets of process, okay, they are divided into set of programs or submodules. Okay. So those comprise a bigger program that is to be called to be algorithm. Okay. Now so those, since they are different algorithms, now they have different execution time. Okay. Now suppose you are taking one bucket, you will take more time. If you take two bucket, it will take less time, around half of time it will take. Okay. Or if you use machines or conveyor belt or other moving vehicles like skating, all these things, so that will reduce your algorithm also. So that reduces the time complexity. That means number of operations or time execution time for completing the task. That is the overall idea. So this is where you should do analyze the program or the algorithm, set of each instruction, okay, each line by line instruction, and see which operation are taking more time. So in your case, in your example, you are using loop. So you will go to the well with a 5 liter bucket, then fill the 5 liter bucket, then go to your tanker, you fill the tanker, then come back to well. Okay, so this loop will continuously work on till 10 times. Okay, so filling the bucket and filling the tanker, that will take some constant amount of time, that is denoted by order of 1, okay, or order of k. That means O of k. So that is a notation. How do you represent the time complexity? Okay. So filling your bucket or filling your tanker takes around 2 minutes or 3 minutes. Okay. So total it will take 5 minutes. So 10 into 10, that will be 50 minutes. Approximately you can say that it will take 50 minutes to fill a tanker with a liter bucket from a well. Okay, that's it. So this example also say like that. So I have used a addition operation. For C is a variable, A also a variable, B is a reversal, which are of integer data type. I am adding int C is equal to A plus B. Now this operation will take some constant amount of time. Constant means fixed amount of time. You can say that roughly it will take this nanosecond. Okay, or 10 nanosecond, 100 nanoseconds. Suppose 100 nanoseconds, no issue. So the computer can execute this instruction with 100 nanoseconds. But if this operation can be done with 1000 times, I will run a loop for int I equal to 0, I less than m, I plus plus. So you know, if I run this m is equal to 100 times, m is equal to 1000 times, then this will take 1000 into 100 nanoseconds. Now that time is very significant. That's why I am multiplying the number of iterations into order of that constant time. Okay, but the constant time, that is always a fixed value. uh, you can say, you can blindly say no approximation or no nothing, that this will run in this machine with this much amount of time. Okay, that is order of 1 or order of k. This is the first thing. Now let's come to second thing. Okay, so this is a little bit complicated. Okay, no issue. Now, how to measure this time complexity of an algorithm? There are three basic notation: order of n, so that sigma n and theta n, omega n. Okay, yes, omega n, and this is theta n. Then I can say what is big O of n. Okay, what is n? N, suppose n is the number of key elements in your program or in your algorithm. Now from now on you say it algorithm. Okay, so there are n number of inputs. Suppose you are adding 100 numbers, so n equal to 100. Now that will be on the x-axis. That is the number of inputs or number of key elements. Now how much time it will take to do those operations or taking these elements, that will take along the y-axis. Now the analysis, that is called asymptotic analysis. The keyword you should remember, no need to worry about now. Okay, asymptotic analysis. This is the process to estimate the time complexity of an algorithm or calculate the time complexity of an algorithm. So that's why the y-axis, you remember the time, how much time it will take. Suppose n is equal to 10. So you run the program, then you plot the graph. How much time it will take? Suppose 1000 nanosecond. Now you increase n is equal to 100. Now it will more. Okay, time consuming will be more, execution time, right? What is the difference between execution time and waiting time? Do you have any idea about waiting time? What do you mean turnaround time?
Sir,
Turnaround time. Okay, no issue. No issue. So suppose this is the only we are calculating execution time. So n, suppose n 100. So that time will be more. So you plot the graph. Okay. So how can I say that this my time complexity is of order of n? This O, big O of n. How can you say? When I will apply this approach, okay, so you show the time is that the y-axis is almost having a slope, like, okay, straight line and slope, and that is the order of n. So this is simply depends upon the number of inputs. Sometimes the graph, the function will be non-linear, okay, but you don't know what is the what will be the this particular output of how to find the time complexity of those program or algorithm. But you know specific function which are fixed, like order of n square. F of n is equal to n square, or g of n is equal to n square. Okay, g of n is equal to n cube, g of n is equal to log n. So now you apply those things, you can derive a formula or derive a conclusion that my curve, okay, which I have plotted with this output, n is taking the number of elements, that comes closely below that curve, known curve, that is either exponential or log n or n square n cube similarly, so that you can close your eyes and you can say that my algorithm is almost like order of n. Now let us take this order of n or order of gn. You can say order of gn. Okay, f of n is equal to order of gn. Since g of n is equal to linear, now you can say that is order of n. Now this looks very complicated. Let us take an example. Okay. Now you are going to Howrah, Kolkata. You see a bridge, Howrah bridge. Now you come to Cuttack. There is a bridge. Okay, but you didn't measure the height of those bridge. You can say that Cuttack bridge is, or Naraj bridge is smaller than Howrah bridge, but you don't know the exact nature, exact height of the bridge, Howrah bridge or the Cuttack. You can say you will compare and come to conclusion that our bridge is just smaller than how much smaller? You can say half of that, or 1/3 of that, or some possible. So that 1/3, 1/4 is c, that is constant c. Now g of n is the height of Howrah bridge, and f of n is the height of our Cuttack or Naraj bridge. Okay, so that you can say, I can say that my algorithm runs, or that height is Howrah bridge se chota hai. Howrah bridge is the reference. So similarly, there are some specific known functions. You can guess that my algorithm runs under order of n square. n square से ज़्यादा नहीं होगा. You can say आज कितना वैल्यू है टमाटर का, नहीं भुवनेश्वर से तो कम ही होगा. You can say, right? So Bhubaneswar rate is the reference one. Now you can say that is the g of n, that upper curve. Okay. So you don't go to further into detail. You will learn also in this algorithm in third year also or final year. So no need to worry. Just remember those things. This will be helpful. How to calculate your time complexity with this notation, order of n. You can say my algorithm almost run with single loop, order of n, or double loop, nested loop, order 2 loop, so order of n square, 3 loop, order of n cube. Okay, now come to second part. So there are other notation like omega n and then theta n. Omega n is the reverse of this one, order big O of n, and theta is the average case of n. Okay, so that we'll see. We will see one example, then we will compare. Now coming to another representation. In time complexity can be represented as recursive representation. Suppose I have already given you one assignment to find the addition of n numbers. What will you do? You have got an array. So first retrieve the first element 0, then you call recursively other elements. Sum is equal, sum of n is equal to sum of a of 0 plus sum of a n minus 1 to n minus 1, remaining n minus 1. Okay, so that can be represented in recursive way. So similar time complexity also. So that means if a program or algorithm takes t of n time, this is a function, t of n function. So the other sum module, okay, so that can take n minus 1 time. Okay, small bit of n number of programs that can take n minus 1, t of n minus time plus some constant. Now you have to solve this recursive recursion, and you finally get the result. What will be the value? Okay, so there are some procedure we can calculate. So First of all, you can represent the time complexity of an algorithm in this recursive way also. Okay, coming to this our important chapter. Now we will calculate the time complexity of a some operation. So you already know definition of data structure. What do you mean by data structure? Okay, and we'll start with single linked list. So there are, you know how to, suppose you have plenty of books in the library and you just arrange them in random order, just sort of keep in table in random order. So now you go and you have to look for a book on data structure. So how to find it? Will be very difficult. If books are ordered and kept in a particular arrangement, then it will be easier for you to find your book data structure. Suppose I will arrange the book in alphabetical order. So in A you will store algorithm, B you can make a basic programming, C like C in data structure. Okay, similarly on alphabetical order, if you sort, then you can find, you go to D rec and you will find different books, and you will obviously find that. That is the arrangement. How do you arrange your data? How do you structure your data? Okay, similarly if you structure your data, your life will be very easy. Okay, so program will run in efficient manner. So for that purpose, so programmers and scientists have proposed different type of data structures. Single linked list is one of it. Okay, so what is this structure? How they are keeping data in this way? So it is a linear data structure. Now question why? You will gradually come to know why. It is a linear data structure. Remember, this is a linear data structure. Now you keep data in a particular memory. That memory usually called as a node. Okay, so in Java, how do you represent? You define a class. So in that class you represent two types of data. One is data, another is next. Next is a address. Okay, suppose you are a student. Okay, you have your roll number, your book, your bag. Okay, so those are your data. Now you hold your section or branch address. Okay, ID card. So that is your next address. Okay, so similarly in each node also it comprises two type data. One is in one data. So in data field there can be a number of data you can put, and it will in the next part you can keep a address which is nothing but the address of next node. Okay, just imagine a link or chain. Okay, so one bead or one node is connected with another node. How do they connected? The end part is connected with the first part of the another chain link. So this is the point, arrow point. Okay, this next address pointing to the another node. Now you will ask why this arrangement or structure? What will be helpful? It is helpful when, okay, suppose you have a large number of data and you will have the address of the first node. Okay, so what you will do? You don't need to store all the elements and pass to the calling function. Suppose I want to search an element in array. If you store in a single array, okay, so you have to pass the address of the array. Do we pass the whole array? No, we are only passing the address of the array. Now, how do you search the element? You go to the first element, then you go to the next element. How do you go? You just using index I plus plus. Increment the index, then you search the element if it is there or not. In this type of structure, in linked list or singly linked list, the only header address, the starting node address will be given to you, and you have to do all the operation. What are the operation? Insert, delete, and search, and display. Those are 3 and 4 basic operations you can do over those linked list. Now imagine, but in the array you are going sequentially. Here you cannot go sequentially. You can jump to another memory address. So that memory address can be anywhere in the memory. This is a certain advantage. Okay. We won't discuss more detail. Okay. This is the advantage over the other approach. So you can keep randomly object in anywhere. Just think, imagine like you are keeping book in the library. Okay. And suppose we are keeping third semester books. Okay, alphabetically you will start from A, B, C, D like that. With that also keeping the third semester book. First go to first element, first book. It holds the address of another book. Suppose there is the address, you can say other book also there, other copies also you can find in that particular address. Now this will be useful to you, right? You can go if you not find the book. Suppose 2 friends or 3 friends have gone to library. Now only one can issue the book, only because there is one copy. But if suppose there are multiple copies, okay, because they are in the same rack, they are all stacked in. You can get those books one by one. What if there is another rack in different location in the library? Okay, since at least 50 books you can keep. Suppose there are 1000 books, 50 such books, but in the different floor. But you don't know the location. Suppose you go, 3 people go, and only you have found only one book in that rack. But that book has the address of the next book's location. That in the third floor, in the particular rack, in the D rack, you can find we may have find another book. So you go to that book, you can find there are 2 other books, 2 other copies. So totally you can issue 3 copies. So this is a very useful scenario where you can use single linked list. Okay. So now coming to Java. Now how do you represent those node? So each node there are 2 fields. One is data, another is address. So you can represent this class node. Inside that the data type and data, and then next the is pointing to the other address, other node address. That is of which data type? That is the same data type. That is also a node. So that's why I have point here or type here the data type node next. Okay. So suppose there are 4 elements. 1, 2, 3, 4. Then the last element will have the next address, that will be null. Okay. So we can say that is the tail end of the single linked list. One is starting node, one is the tail end or the end node of the single linked. Yes. So what are the basic operations you should do? First of all, create a node, create a single linked list. Okay. Then insert an element in the single linked list, delete an element from the single linked list, display all elements in single linked list, and search for an element in single linked list. First of all, how to create a node. Now look at this class. Now tell me in Java how will you create a node? Any suggestion? How do we create a node? You declare a class node int data node next, then you instantiate the object, create the object, then you can use getter setter or dot operator, we can put data and next. Let us see in the Eclipse. Okay, so first of all we go in the project, in the source we create a package, name this as SLL. Don't comment create package, don't click on this create package info, just finish. Now inside this package you create a class SLL test. Click on this main method. Now this is the class. Okay, now here I declare this node, class node in data node next. Okay, now first thing we were going to create a node. Our task is to, first task is to create a node. Let us see how can you create a node. So this will be data. What data? It can contain integer type data. This is a very simple example, so we are not complicated it. You can use other type of data also. There may be multiple data. For time being, this we are keeping it very simple. Only integer data. Okay, one data field, that is data. And now it will have a next address. What is the type? Node next. Okay, so we have created a class of this type, node int data and node next. This will store the address of from next node. Now in public static void main string, just call this as a create object node. Suppose let's start this p, node p is equal to new. No. We are creating object, right? So now p dot data, we can give a random value, and p of next, p dot next equal to null. Perfect, right? So this way you have created a single node. So how can I represent? This way. Okay, only one node I have created. See, yes, I have created data, and the next, then next is null, right? Is null. Now imagine imagine a train bogies. Okay, train bogies, right? So metro train or passenger or any express train. So this the start head or the head node is the engine, where the engine will be there. Okay, and the rear end or the last end where the null is there, that will be tail end. Okay, and in between those bogies there is a link. Just imagine like that. Now our first task is we have created a node, so that will be our first node. Now we have to create a single linked list. Now we have successfully created a node in the program. Okay, now I want to create a list. Now what will do that? I will keep on creating a node and add to the this created a node already. Okay, so I will create another node. Just let us see. Okay, then append to there. Okay, so just like the buggy are added to the engine. So this is our engine, the first node. I am adding another buggy. Okay, now I will point this also to null, since this is newly added node. So there will be no link to the last node. There this is a train which is having engine and another buggy. Now I will create another node and append after this one node. Okay, so in this way you will create a single linked list. Now what will be this helpful or benefits of using this, you will see in the next class. Okay, now we will give a pause, you will have a break, then you just ask any doubt till now. If there is any doubt, we will stop here for a moment. Any doubt?
No, sir.
So can you create another node and append to this node created node? So how do you do in this in our program? How can I do? Now we have created a first node. First node we have created. How can I do? I can create similarly. I can call another node. P. I will suppose Q. Then key of data will be 200 and key of next will be then what will I do? I have to adjust this element. Now this is our head node, this is our another buggy you have to append. Now p of next will be, what will the p of next? That will be q. Okay, can you write like that? You will not get any thing, right? Yes, so that's why